Welcome everyone. Let's study today about evolution of star. That means changes in the star during the formation and stages of the star. So let's study. And this topic is from lesson life cycle of a star for part 3 of this lesson and class 8. Alright, so let's study evolution of a star first. Student, evolution of a star means change in its properties with time resulting in its passing through different stages, and we have seen that the properties of the sun have not changed in the past 4.5 billion years, and the properties of sun will be same for this period of time, and stars evolve very slowly for most of their lifetime. That means the changes in the properties of a star are changing very slowly during their lifetime. And as stars are continuously emitting energy, their energy is constantly decreasing. As light energy is emitting continuously by the star, so the energy will be decreasing. And for their stability to remain intact, that is for maintaining a balance between the gas pressure and gravitational force, it is necessary for the temperature remains constant. So as pressure of hot gases like hydrogen and helium and all other gases, and between the gravitational force, there should be balance, and for this balance or stability of the star, the temperature of the star should be constant. And for the temperature to remain constant, energy must be generated inside the star. That means energy should be forming continuously. Generation of the energy should be taken place in the star, and we know the fuel of the star is hydrogen. And this generation of energy occurs because of burning of fuel at the center of the star, and we know at the center of the star gases are there like hydrogen, helium, and several other gases also are there. And the reason for the evolution of a star is the burning of and therefore the decrease in the amount of fuel in their center. When the fuel in the center finishes, the energy generation stops, and as a result the temperature of the star starts decreasing, and due to the decrease in temperature the gas pressure decreases, and the balance between gas pressure and the gravitational forces cannot be maintained, and star loses their stability. As the gravitational force is now higher than the gas pressure, the star starts contracting, and this causes another fuel to start burning. For example, when hydrogen at the center is finished, helium starts undergoing fusion and energy generation starts again with the help of a helium gas. And here one question is there: how many fuels will be used depends on the mass of the star. So higher the mass of the star, higher is the number of fuels used, and during this a lot of changes occur in the star, and as a number of processes occur inside the star, it sometimes contract and expand, and at other times, and the star goes through different stages. So evolution of the star taken place happening continuously during their lifetime, and the balance between the gravitational force when all possible fuels are exhausted, the energy generation finally stops, and the temperature of the star starts decreasing, and the balance between the gravitational force and gas pressure cannot be maintained. So student, let us now see how the evolution of the stars ends and what end stages of stars are. So end stages of the stars, student, the higher of the mass the star, faster is its rates of evolution. That means if the mass of the star is higher, so the rate of evolution will be higher. And the different stages during the evolution of the star, which is the path of evolution of the star, also depend on its mass or weight. So how does the evolution finally stops? We have seen that when the energy generation stops, that means when all the fuels in the star exhausted, so the energy generation will also stop, and when the energy generation is stopped, the temperature of the star start decreasing, and the temperature decreases, causing the gas pressure to decrease, and the star contracts and its density will be increases. So as the temperature decreases, density will start increasing. And when the density becomes very high, some new types of pressure are generated which do not depend on the temperature of the gas. And in such case, the gas pressure remains constant even after the energy generation stops completely and the temperature of the gas goes on decreasing. And the stability of the star can remain intact forever, and this can be considered as the end stage of the star. Alright, so there are three ways of evolution of stars depending on their initial masses. So thus we can divide the stars in three groups. The path of evolution and end stage for all the stars in the same is the same group is the same. Now student, the end stages of the star having the initial masses less than 8 times the mass of the sun. So these are the different end stages of the star. And second one is the end stages of the star having mass between 8 and 25 times the mass of the sun. And last is the end stages of the star having masses larger than 25 times of the mass of the sun. It means the mass of the sun is greater than mass of the star are greater than the sun. Now let's study the first time, that is end stages of the star having initial mass less than 8 times the mass of the sun. So these are the star having masses less than that of the sun. So student, stars in this group undergo huge expansion and their radius increases by a factor of 100 to 200 times, and in this state they are called as a red giant stars, and this name is given because of the large size and because of the fact that the stars look reddish due to their lower temperature. And at the end of its evolution, these stars explode and their outer gas envelope is thrown out. And the inner part contracts and its size becomes similar to the size of the earth. And as the mass of the star is much higher than that of the earth and the size is similar to that of the earth, the density in the star becomes very high. Alright, so in this state, the pressure due to the electron in the star becomes independent of temperature and is able to balance the gravitational force forever. And in this state, the star looks white, and due to its small size, it is called as a white dwarf. And after this, its temperature keeps decreasing, but its size and mass remain the same or unchanged forever. And so white dwarf is the end stage of stars in this mass range. Student, here you all can observe the evolution of stars based on their masses and their end stages. So here, this is a small star, red giant. That means after the evolution of the interstellar cloud, the small star formed, and then after it becomes red giant of a smaller mass, and the end stage is the white dwarf. You can observe the white dwarf. Alright, now we have the end stages of stars having mass between 8 and 25 times the mass of the sun. So student, these stars also go through the red giant stage and later through the supergiant stage, during which their size may increases 1000 times. So here you can observe the red supergiant below side. It is very greater than the large star, and the huge explosion called the supernova explosion, and which occurs at last is very powerful, and so much energy is given off that we can see the star during the day also. And the central portion which is left behind after the explosion contracts and its size becomes as small as about 10 km. And in this state, the stars are completely made up of neutron and are called as a neutron stars. So these are the neutron stars. Alright, so student, here you all can observe the picture, a recent picture of the supernova explosion which was first seen in 1054 AD. Alright, now the third stage is the end stages of the stars having masses larger than 25 times the mass of the sun. That means these stars having the masses greater than the sun. So these stars evolved like the star in the second group, but after the supernova explosion, no pressure is capable of balancing their huge gravitational force, and they continue contracting forever. As their size becomes smaller, their density and their gravitational force increases tremendously, and all nearby objects get attracted towards this star and nothing can come out of them, not even light. and also any light falling on this star does not get reflected and get absorbed inside the star, and thus we cannot see the star at all, but can probably see the minute black hole at its place. So this is a black hole. Student, as the size of the white dwarfs is similar to that of the earth, their density is very large, and one spoonful material of the white dwarf will weigh a few tons. And as neutron stars are much smaller than the white dwarfs, their density is even higher, and one spoonful material of these stars will be as much as the weight of all living beings on the earth. So this is much greater in size or mass. And a star in our galaxy exploded about 7500 years back. As the star is about 6500 light years away from us, the light emitted in the explosion took 6500 years to reach us, and it was first seen on the earth by the Chinese in the year 1054 AD. It was so bright that it could be seen during the day also for 2 years, and after 1000 years of the explosion, the gases emitted during the explosion are seen to be expanding with velocities higher than 1000 km per second. Alright, so depending on the mass, there are 3 parts of evolution and 3 stages of a star we have seen. So here one table is given to us in which the initial masses of the star and the end stages of the star is given. So here first is the initial end stage of the star having initial masses less than 8 times the mass of the sun. So this is the end stage of this star is a white dwarf, and second is the stars having masses between 8 and 25 times of the mass of that sun. So it is the end stage is neutron star. Why? Because the neutrons because the pressure of this neutron is independent of temperature and is capable of balancing the gravitational force forever. So these are the end stage is neutron star. And next is the end stage of a star having masses larger than 25 times the mass of the sun, and the end stage of this type of a star is black hole, okay, in which the light also getting absorbed in this black hole. Why? Because the gravitational attraction is very much higher in this type of end stage of the star. So student, that's it for today. I hope you all have understood this complete lesson, and here we have finished this lesson. Thank you.